Hello, all of you. Now, in today's session, we will see what are the activities that are performed by this language processor. So, and also the very important topic that is fundamentals of language processing. So, the activities basically the performed by this language processor are the one that is the program generation activity and program execution activity. And don't confuse between these language processing activities and fundamentals of language processing. Fundamentals of language processing means what? That is analysis phase and synthesis phase. Also, you can call this analysis phase as a pass one that you can see here, and then that is the next for the synthesis phase, that is the pass two, right? And also the another name for this analysis phase and the pass one is front end, and for this synthesis phase and pass two, it is a back end. So just remember the different names of this. We can say that that is the fundamentals of language processing. Now, one by one, we will cover today all these topics. So the first one, that is the language processing activities. So in these language processing activities, first activity is that is program generation and second activity is program execution. So now first one, that is the program generation. So you can see here one block, that is the program generator. Input to this program generator is specific program specifications, and then output is program in target period, right? So the program generation activity can be automated. So the source language is a specification language of an application domain, and the target language is a program in a programming language, right? So now here simply we can say here in PPT that in slide that is program generator domain is introduced in between this application domain and target PL domain. So it occurred in between these two domains. Here you can see in this diagram program generator domain. So the program generated is a software which accepts the specification of a program to be generated and generates a program in target programming language. So it is easy, first of all, easy to write a means write the specification of a program rather than writing the entire program in a programming language. And generator program is more reliable. Though, so the program generator bridges the gap between this application domain and programming language domain. And one more thing, that is it is more economical to develop a program generator than to develop a problem-oriented language, right? So program generators are restricted to specific application domain. It is not possible to develop a generalized program generator, right? Just remember these things. The execution gap, right? We know that what is the definition of execution gap that we have seen in last lecture. So the execution gap between the programming language domain and the execution domain is bridged by the compiler or interpreter, right? So what are the examples? So you can see here one example. This is the one of the program generated. So form filling, right? A second example, screen handling. So you can see here one of the form filling example is there. Right, so different headings are there: employee name, address, married, age. So it is the one of the best example of program generator. So now next one is program execution, right? So in this program execution, so two models you have to remember. What are these two models? That is, one is translation and second one is interpretation, right? So program translation activity involves the translation of a program from source code to machine code. So for example, compilers can be used for the program translation. Right? We have seen the different examples of these translators. So that translated program may be saved in a file, and the save file may be executed repeatedly. Right? So just remember some points. A program must be translated before it can be executed. So before execution, you have to translate your program. Second one, translated program may be saved in a file and the save program may be executed repeatedly. Right? So yeah, it's easy. So now the program must be retranslated following the modification. Suppose you want to do some modifications, right? And you have done that modification since the source program. Then you have to translate it again. You cannot use same program for the execution. So these are the three important points related to this program translation model. Now, second one, that is program interpretation. Right? So here, simple one, you can means apply the interpretation concept here. So interpretation in interpreter, that is the statement by statement execution is there. So here you have to follow these three steps. That is fetch the statement, right? So analyze the statement and determine its meaning, right? And then execute the meaning of the statements. So the program can be executed by this interpreter. So simple, we know that the interpreter reads the source code one instruction at a time and converts this instruction into the machine code or some intermediate form and execute it. So these are the simple diagrams to remember this program interpretation model. So then our next concept is fundamentals of language processing. So the language processing consists of the two phases, that is analysis of source program and synthesis of target program. So this SP and TP means source program and this is target program. Right? So the collection of LP means language processor components engage in analysis. A source program as the analysis phase and components engage in the synthesizing a target program constitute the synthesis phase. Simple definition. So now we will go into detail of this analysis phase and synthesis phase. So first of all, in this analysis phase, three types of analysis are executed, or we can say that is the done by this language processor. So first one, that is lexical analysis. Second one, syntax analysis. And third one, semantic analysis. So in this synthesis phase, two tasks are done. These are the very important tasks. So first one, memory allocation, and second one, this target code generation. And also this analysis, lexical analysis is called as a scanning. Then this syntax analysis is called as a parsing. So the language processor contains analysis phase and synthesis phase. And this diagram beautifully explains the language processor concepts with these two phases of language processor or fundamentals of language processors. That is one analysis phase which is related to source program and this synthesis phase which is related to the target program. Again, remember this analysis phase analysis the source statement contains lexical, syntax and semantic analysis. This synthesis phase, it constructs the target language statements for the source statements. So now in this analysis phase, we have to apply some rules. So first one, lexical rules. So lexical rules which govern the formation of a valid lexical units in the source language. The next, syntax rules related to syntax analysis, which govern the formation of valid statements in the source language. And third one, that is the semantic rules, which associate meaning with valid statements of the language. Right? So now next, one example is there. Now by using this example, we can understand what happened in these three types of analysis. So percent profit equal to profit into 100 divided by cost price. Right? Apply the lexical. Lexical analysis means what? Scan. And it forms the token, generates the token. So here we can see that is the different types of tokens, that is operators, constants, identifiers and separators. Total four types are there for this token generation. So what do you mean by operators? Operator means all the operations or the operating symbols you have used into your mathematical equations. Now constant, 100 is a constant. So one token is generated, it is called as a constant, that is the 100. So this percent profit, cost, price, these are the identifiers. And semicolon brackets are the separators. So 4 types of tokens are there. So what will happen in this syntax analysis? So syntax analysis identifies the statement as an assignment statement with percent profit as the left hand side and the profit into 100 divided by cost price as the expression on the right hand side. So syntax analysis checks whether LHS equal to RHS. And the next one, that is the semantic analysis. So semantic analysis determines the meaning of the statement to be the assignment of profit into 100 divided by cost price to the percent profit. So in this semantic analysis, the meaning of the statement is checked. So in lexical, just revise, that is the tokens are formed, different tokens. Then in syntax is checked, and in semantic analysis, meaning of the statement is checked. Right? So now next one, that is the synthesis phase. So synthesis phase is concerned with the construction of a target language statements which have the same meaning as a source statement. So what are the two main activities? That is, one is creation of a data structures in the target program, that is memory allocation. And second one, generation of a target code, that is a code generation is there. Right? So now for the same example, we will just write the output of the synthesis phase, or we will complete these two tasks. So what is our example? That is percent profit equal to profit into 100 divided by cost price. So write a code. So move a register comma profit. First of all, take the profit. Obviously, we have to solve first of all this bracket. So profit is stored into the A register. Then multiply with 100. So mult, that is the A register comma 100. Then what is that? That is divide by cost price. So division operation A register. So because result is stored in this A register by cost price. And this output you have to shift it into percent profit. So move M A register comma percent profit. Right? So now next, memory allocation. Allocate the memory. So for the percent profit and cost price, you have to allocate the memory. So here I have allocate the word, define word DW. So how many words? That is 1 for percent profit. So for only profit, DW1. Cost price, defined word, that is the 1. So it totally depends on you. Suppose you think that key byte is sufficient, so you can write here define byte 1. Suppose you think that 2 words are required, then you can write here. So it is totally depend on the developer. So the now next, that is the phases and passes of language processor. Again, this is the very common question into the exam, that is write a passes or explain the two pass language processor or different phases of language processor. So this diagram you have to remember. So analysis phase and synthesis phase. Right? So analysis of source statements cannot be immediately followed by the synthesis of equivalent target statement due to following reasons. So we have seen that is both the phases of this language processor, but now the problem is that analysis of this, we can say that in this analysis phase, analysis of this target program is not immediately followed after the completion of this source analysis of source code. So why? What is the reason? That is first one, forward reference. And the second, issues concerning memory requirements and organization of a language processor. So what do you mean by forward reference? Very beautifully we can see this forward reference topic, and very important. So first of all, forward reference of a program entity is a reference to the entity which precedes its definition in the program. Right? So just remember, it is a problem and we have to solve it. So if we declare the variable type after the calculations, it becomes a forward reference. Just remember these two examples. We have seen this example, percent profit equal to profit into 100 divided by cost price. So you are using this into your program. You have declared it or you are calculating the output for this one. But what happened? You don't know that key what should be the type of this profit. So what happened? Ki developer has declared this type of this profit at the end of program after the calculation, after the using this mathematical equation. Right? And it is called as a forward reference. Same here, A equal to B into 100 divided by C. Initially, when you are using it, so you don't know that shall I declare it as a long or not, because you don't know the requirement. So after the finishing of this program, after using it, after calculating, you declare and you realize that it should be the long B. So this is an example of forward reference. So the information concerning the type of profit divided by B is noted in the pass 1 and used during the pass 2 to perform the code generation. Because this information is required in the synthesis phase and you have declared, developer has declared it after the calculating the answer of this equation. So it is not possible to generate the code. So that is the reason that synthesis is not immediately followed. Okay. So now intermediate representation. So first pass 1 and pass 2 is there. Now you are familiar with this word. So perform the analysis of source program and note the relevant information. And pass 2 again analyzes the source program to generate the target code using the information in pass 1. So you can see in both the passes there is an analysis of or the scanning of your source program is there. So we have to avoid this double analysis of source program. So how you can avoid this one? By using this intermediate representation. Okay, so intermediate representation of source code. So IR means what? Intermediate representation is representation of a source program which reflects the effect of some but not all. Right, just remember. So analysis and synthesis tasks performed during language processing. Okay. So then now next we will see multipass model. Now we know that is you can easily observe this diagram. So source program is input to pass 1, right? Now the output of this pass 1 is intermediate representation, and this intermediate representation is input to pass 2, and finally we are getting target program. Right? So pass 1. So concern exclusively with the source language issues. Hence it is called as a front end of the language process. Now pass 2. Pass 2 means this one. So concern with the program synthesis for a specific target language, hence called the back end of the language processor. Front end and the back end need not reside at the same time in memory, so the memory requirements reduce. And here also we have avoid the double analysis of the source program, because pass 2 is using the intermediate representation of your source code. So what are these properties of this intermediate representation? So first of all, ease of use means IR should be easy to construct and analyze. So when your IR is generated at that time, it should be the very easy to analyze. Second one, that is the processing efficiency. So efficient algorithm must exist for constructing and analyzing the IR. So there should be the proper algorithms for construction and analysis of this IR. And third one, that is memory efficiency. IR must be compact. It should not be larger than your source code, because memory is again a very, very important point is there that we have to consider while developing the application. So these are the some property that are required while constructing this IR. Right? So now we will see one toy compiler. So all these things we have considered that are related to means compiler itself, but we will go in detail of this toy compiler. Right? So the front end. Now you know that front end, pass one, analysis phase. So input to this one is the source program and it reflects its results into IR. Now the back end. So second pass reads and analyzes the IR instead of source program and perform the synthesis of target program. Okay. So now next, again here I have written all the names, analysis phase, pass one, front end, synthesis phase or pass two or back end. Right? So first one, lexical analysis. So this is for a particular compiler. So it identifies the lexical units in a source statements and then it classifies the units into different lexical classes. Right? So it builds a descriptor and that descriptor is called as a token, right? And that is for the each lexical unit. So these tokens contains the two fields, that is first one that is the class code and then number in class. So what do you mean by this class code? So the class code identifies the class to which the lexical unit belongs and the class number in class is the entry number of the lexical unit in the relevant table. So we define a token. So first that is the code hash number. For example, ID has 10. ID means identifier. Okay, let us see now an example. So this is a simple example. So I integer, a comma b real and a equal to b plus I semicolon. So here you have to form the different tables in this lexical analysis. So just consider this example of symbol table. So here you can see, so the first symbol, first identifier is the I. What is the type? That is integer. Now next symbol you can see that is the A. What is the type? That is the real. Next one is the B. Serial number is 3 and this is the real. Okay. So next you can see here that is I star, that is the real, and fifth symbol is temp, that is the real. So now we will see why this I star and temp is required in this analysis. Right? So now based on this, by using these tables, we have to write the lexical means tokens of this for this A equal to B plus I. So likewise, the symbol table, different constant tables are there, different we can say operators tables are there. And this serial number, this numbering is very, very important to write the token for that means source code separators. So first one that is A equal to B plus I. So what is the token for the A? A is identifier. So write here code that is ID, then this hash. Then what is the number for this A? That is the 2. So here to write the token for this A, you have to check symbol table. So now next is equal to. Okay, like a symbol table, there is a one more operator table is existing. So what is the code? That is OP. Then hash 5. 5, what is this 5 indicates here? That the number for this equal to in operator table is 5. So next is that is this B. B is identifier or symbol. So check the symbol table. So what is the number? That is 3. So how you will write? That is ID hash 3. Now next one that is the plus. So it is operator. So write OP, check your operator table. So here 3 indicates that the number for this plus is 3. Next one is that is the I. So I is identifier, hash, number for this I is 1. And next, last that is semicolon, it is operator and number is 10. So these numbers are serial numbers into your table. Right? So now next, after this lexical analysis, we know that syntax analysis is there. So output of this lexical analysis tokens are input to the syntax analysis. So it processes the string of tokens built by the lexical analysis to determine the statement class. Then it builds an IC which represents the structure of a statement. And the IC is passed to semantic analysis to determine the meaning of the statement. So pass tree. Okay. So here simple, first of all understand that real means A and B. A, B are real. Okay. So you have to draw here, you have to generate the pass tree for your example. Example is very simple. A equal to B plus I. So first of all, we know that in syntax analysis, first of all check LHS equal to RHS. So always start with this equal to sign. What is on LHS side? That is the A. What is on RHS side? That is the B plus I. Now B plus I means obviously plus sign you have to consider, and this is again LHS, that is the B, and here that is the I symbol is there. So always check from the bottom that the B plus I, then which is equal to A. That is LHS equal to RHS. Right? This is the output of the syntax analysis, that is the pass tree. Now next one, this output of the syntax is input to semantic analysis. So what do you mean by semantic analysis? So it identifies the sequence of actions necessary to implement the meaning of a source statement. Right? So here it checks the meaning. So it determines the meaning of the subtree in the IC. It adds the information to a table or adds an action to the sequence of actions. So, and the analysis ends when the tree has been completely processed. Right? So this is the your syntax output. So A, then equal to sign plus B and integer. But here you can see you will get the error in this semantic analysis because this B is with variable type real and this I is with variable type integer. And the addition of this real and integer is not possible because two different data types. So here you will get the error in this semantic analysis because semantic analysis checks the meaning. So what is the solution? So first of all, convert this I into I star, that is integer into real. So I star is there and it is real, and then you can easily do the analysis. So B and the I star addition, that addition is stored in the temperature. So not temperature, temp variable. So which is real, and that is equal to A. Right? So this is the your semantic analysis output. So now this is the front end of compiler. So source program is input to your scanning, that is lexical analysis. Then output of this scanning, that is lexical analysis, that are the tokens that are input to your syntax analysis. Also it is called as a parsing. And here the output is a trees and that are input to your semantic analysis. At the same time, if there are the errors, you can get the errors, that is lexical errors, syntax errors, semantic errors. And at the end, IC code is there. And with these tables, also these tables are generated. With this one, it is called as intermediate representation. Right? So now next one, that is, we will see how to write the intermediate representation for our example. So our example is very easy. A is equal to B plus I and all the tables are ready. So just follow the flow. This is not the exact intermediate code, just follow the flow. That is, first of all, what you have to do, we have to add B plus I, but this I is integer and B is real. So first of all, convert this I to real. So convert. So what? That is ID comma hash 1. So here don't use directly the alphabets, that is you cannot use here I. So instead of that you have to use the token. Token for this I is ID hash 1 to real, and giving ID comma hash 4 means this is the I star. Now next add that ID hash 4 to ID 3. What is that ID 3? This is the B. So B plus I star giving ID 5 means the result is stored in temp variable. Now next store what that is ID 5. ID 5 means what? That is the temp. In what? That is the A. So in ID 2, 2 means what? That is the A. So this is the flow to write the intermediate code, right? Now next one, that is the synthesis phase. Now synthesis phase, we will use that intermediate representation for the synthesis of this target program. So first task, that is memory allocation. So the memory requirement of an identifier is computed from its type, length and dimensionality, and memory is allocated to it. The address of the memory area is entered in the symbol table. So symbol table is ready. So now you have to give the address. You have to allocate the memory. So here you can see that it 2000. We have started with the 2000, then 2001, 2002, like this. And at the end, you have to generate the code. So it uses the knowledge of the target architecture. So to write a code, you should know the architecture of your processor, right? So instructions, you should know the knowledge of the instructions, addressing mode used in your target program or target computer. So just flow is that simple. A equal to B plus I, you know that intermediate code, just convert it. So A register comma I means I is stored into the A register, then it is added with this B and move M, that is A register to the A. Finally, the results are moved to the A variable, right? So very simple to write this code because example is very easy. So here we have finished, that is the synthesis phase, backend of your compiler. So in this backend, you can remember that is one is memory allocation and second one is code generation. So that IC code, intermediate code is used for this generation of this target program, right? And at the same time, these symbol tables are generated, which are generated in the analysis phase, are used for the memory allocation and for the code generation, right? So this is the backend of our compiler. So one more example we will see to understand this whole process. So z is equal to x plus y into 5 and semicolon is there. So we will apply all these phases. We will go through this all the phases and we will find the output. So first one, so any compiler first of all generate the uniform symbol table. What is this uniform symbol table? So it is the just a list of all the tokens with their types. So z is equal to x plus y into 5. So z equal to x, then plus y into 5, right? Then semicolon. So just here that is the tokens are or types are declared, that is identifier, operator, identifier, symbol, operator, constant, operator. This is uniform symbol table. And then now the different tables are generated, that is symbol or identifier table, constant table, operator table. So how many identifiers are there? You can see that is Z, X and Y. So Z, X and Y and give the numbering 1, 2, 3. So now constant table. So only one constant is there, that is the 5. Number is 1. And then operator table. So operators are equal to, then plus, multiplication and semicolon. So 1, 2, 3, 4. See, numbering is very, very important because in token generation, we will use that number. Now write the token. So token for the Z. So it is identified. Check the identifier table. So where is Z? Z is here. So ID due to identifier hash 1. Number for this one is 1. Now next, that is the equal to sign. Equal to means operator table. So operator is there. So equal to, check the number. That is the 1. So OP hash 1. Next X. That is identifier. ID hash 2. Why 2? Because number is 2. Then plus, that is OP operator hash 2. Next is, that is Y. Y is identifier. So ID hash 3. 3 is number in this table. Next multiplication. Multiplication number is 3. So OP hash 3. Next is 5. 5 is a constant. So check constant table. Number is 1. So C hash 1. And then finally semicolon. Semicolon means where? That is operator table. OP hash 4. So these are the total token generated for this example. Next is analysis of means this syntax analysis and semantic analysis. So here simple is there. So LHS means first of all equal to sign, as I told you, equal to, then on LHS it is Z, on RHS it is X plus Y into 5. Now the question is either plus is there or star is there, multiplication is there. So first of all we have to consider that is the BODMAS. So first of all, suppose you consider here bracket, you have to do multiplication operation. So addition is there and then LHS means X, and here that is multiplication. So check from the bottom. So first of all, do the multiplication y into 5, then this is the output, then X plus the result of that y into 5, and then which is equal to Z. So here the result of this sparse tree and semantic tree is same because data types are same, no need to change the data type. And finally, that is the synthesis phase. So that is memory allocation and code generation is there. So Z is equal to X into X plus Y into 5. So simple. So first of all, move to the register move R, A register comma Y means Y value you have to store into the register because first of all we are doing this multiplication operation. Then multiply A register with this 5. 5 is a constant. Then add A register comma X, add with this X, and then move M A register to the Z. Very simple to write the code. Move all the contents from A register to Z. Now second task, that is memory allocation. So X define the byte 1, Y define the byte 1, Z define the byte 1. Again it is totally depend on the developer. I have considered here byte is sufficient, so I have write DB, define byte. Okay, so this is the synthesis phase for that your example. So for that one you can use the Dumdere book and Donovan to understand this topic. So now this is the complete um, explanation regarding this system programming. So in the next session, we will see the next topic related to the system programming. Thank you so much.